Hello students, today we are looking at all kinds of factoring. The factoring special cases, difference of squares, and diamond methods are all a review. The box method is new. So, how do I factor trinomials is my essential question. Learning intention. I'm learning to factor trinomials. So pause and do the warm-up now. The first one is factoring by grouping, and the second one is by you got the greatest common factor, and then you'll have to see which method you want to use. So pause the video and do the warm-up now, please. Well, I hope you tried. Remember that we're going to put the first two together, and then we're going to put the last two together, and we're going to factor. So if I'm looking at 12x to the third plus 2x squared, what can I factor out of both of these terms? 2x squared, because x squared is the smallest exponent and 2 is the largest common factor. 12 divided by 2 is 6. X to the third divided by x squared is x. Plus 2x squared divided by 2x squared is 1. Okay, now I'm looking at negative 30x minus 5. I also stop and think, I need this middle term here when I factor to be positive. So the only way I can get this to be a positive is if I factor out a negative number. What is the common factor of negative 30 and negative 5? That would be negative 5. Negative 30 divided by negative 5 is 6. Bring the x down because there's nothing to divide the x with. Negative 5 divided by negative 5 is positive 1. Okay, take a minute and look. Do you have any questions? If you do, back it up and look at it again. So, as we finish up, what's on the outside is one factor. What's in the parentheses is the other. Okay, let's look at the second warm-up. Step 1, do I have any common factors? Well, I can factor out a 6. So 6v squared divided by 6 is v squared. 66 divided by 6 is 11. Bring your v down. Plus 10 divided by 6, 60 divided by 6 is 10. Now that we've factored out the 6, let's look at the 10 and the 11. If we use the diamond method, we are looking for factors of 10 that add up to 11. Everything's positive, so both of them have to be positive. The factors of 10 that add up to 11 are 1 and 10. This will be x plus 1 times x plus 10, and we're done. 1 times 10 is 10, 1 plus 10 is 11. So let's review our special cases. As we're looking at this, we're deciding if these are the difference of the special case of squares, perfect squares. So step 1 is the first term of perfect. Well, step 1 is actually, do I have anything I can factor out? No. So is the first one a perfect square? Is x squared a perfect square? Yeah, that would be x. Is 81 a perfect square? Yes, that would be 9. Is that middle term 2 times 9 times x? 18x. That's true. So this is our special cases, x minus 9 quantity squared. What about the next one? Is there anything I can factor out? No. Is the first term a perfect square? Yes. Is the last term a perfect square? If you're not sure about that, let's look at our chart. As I'm going down through it, I get to here and I see 225. And if I go straight up, I see it is 15 times 15. So yes, 225 is a perfect square. Is a middle number 2 times 15 times x? Is that 30x? Yes. Then I know this is equal to x plus 15 quantity squared. That brings us to the difference of squares. So as we look, is the first term a perfect square? Yes. That's x. Do I have a minus in the middle? Yes. Is the last one a perfect square? Once again, look at your chart. When I come down here, here it is, I go all the way to the top, and it's 13 times 13, because I can always go this way too and get the 13. Difference of squares, the only way I can get that middle term to fall out is if I take x plus 13 and then x minus 13. Create those opposites, and it eliminates your middle term. For the next one, can I factor anything out? Yes, I can factor out a 2. And that will give me x squared minus 121. Look at your chart. Is 121 on a diagonal? Yes. It is 11 times 11. Is there a minus in the middle? Yes. It's not prime, it's factorable. So this is 2 times x plus 11 times x minus 11. So if you've got any questions, back up the video and watch the first page again on notes. Okay, so we're going to factor using the diamond method. Step 1, do you have a greatest common factor? Well, I do believe I can factor 2 out of all of this. That'll be n squared plus 3n minus 54. So for the diamond method, I'm looking for factors of 54, it's a negative 54, that add up to 3. To get a negative when I'm multiplying, I know that one has to be positive and one has to be negative. So what are my factors of 54 that differ by 3? Well, let's see. I could do 1 and 54, that doesn't differ by 3. I can do 2 and 50 and 27. Those don't differ by 3. It's divisible by 3, so I can do 3 times 9 times 18. Those don't differ by 3. 18 minus 3 is 15. Does 4 go into it? Nope. Does 5 go into it? Nope. Does 6 go into it? Yes. 6 times 9. 9 minus 6 is 3. So I'm looking at 6 times 9. This is positive. The bigger number will go with that positive, so it's positive 9 and negative 6. So this factors to 2 times n plus 9 times n minus 6. We're done. For the second one on the diamond method, a squared minus a minus 90. I'm looking for negative 90 is what they've multiplied to. And they differ by 1. When I subtract them, I get 1. The only way I can have a negative up here is if I've got a positive and a negative. What are my factors of 90 that differ by 1? I can do 1 times 90. They don't differ by 1. 2 times 45. They don't differ by 1. 3 times 30. Once again, that doesn't differ by 1. What about 5? 5 times 18. Does 4 go in evenly? I forgot to check that one. Nope. So what about 6? Does 6 go in evenly? Goes in 15 times, 6 and 15. 7 doesn't go in evenly. 8 doesn't go in evenly. 9 times 10. 10 minus 9 is 1. So I'm looking at 9 times 10. The bigger number is 10. So the 10 goes to your negative, and the 9 goes to the positive. So this is a plus 9 times a minus 10. And you're done. So if you can find the factors right away without doing a bunch of guessing and checking, that's fine. If not, just go through them all till you do find the correct pair. So you're going to factor using the box method. So if we're looking at this, we know when we get done we'll have x squared minus 15x plus 50. The two numbers we can put in our box right away will be the x squared and the 50. So I know I start with x and with x. But as I'm looking, I'm still using the same thought process. I need this to be negative and this to be positive. The only way that's going to happen is if I'm multiplying two negative numbers here. So it's got to be negative something and negative something. So the factors of 50 that add up to 15. Factors of 50 that add up to 15. Well, there's not very many, so we can do 1 times 50, do not add up to 15. 2 and 25, do not add up to 15. 5 and 10, do add up to 15. So this will be 5x and 10x. So, x minus 10 and x minus 5 are the correct answers. You're using these two numbers, you're just dropping the x. Okay, on the next one, I've got 5n squared plus 10n plus 20. Is there anything I can factor out? Well, I can start out with a 5, and then I'll have n squared plus 2n plus 10. So, are there any factors of 10 that will add up to 2? No. This is not factorable. So the factorization is 5 times n squared plus 2n plus 10. So we'll go through the box method again because we will start using it later when we know what one of the factors is. I know I'm successful when I can factor any trinomial. So I'm factoring trinomials.